Okay, let's see. Share. Earlier, this was super laggy, so I added time to each question. Hopefully, it works this period. Kahoot, yeah. What's wrong with Kahoot? I like Kahoot. Really?
Yeah.
Since when? Oh, come on. It goes. Maybe it's going to be super laggy again because. Have y'all noticed anything like our internet today, like being slow at all in your other classes?
No.
So just me?
It's always slow in Ms. Robertson's class. It's never new service. It's just really slow.
What the hell? Maybe I should have clicked this earlier. What? Yeah, I'm trying to get it to load. It says, okay, there it goes. Loading game pin. Dang, super slow. This is way slower than even earlier. There it goes. All right, there's the pin. Y'all get signed in. Get signed in, and then we can get started. Dude, what the hell? My whole computer's just running slow. I'm gonna plug it back in for a second. All right, anybody not in? Y'all ready? Let's see how well this looks. All right, review. It's only 8 questions. It's super laggy. Teacher has 10 shirts, 5 ties, and 4 pairs of pants. How many different outfit combos are there? Look closely at the thing because it shows you the different.
Infinity. Yes.
Don't pick infinity. The first one says 10 plus 5 plus 4. The second one says 10 times 5 times 4. The orange one says 10 divided by 5 times 4. I added time on each question because it's been lagging. Good. You multiply across, find combinations, fundamental counting principle, 10 times 5 times 4 is 200. Okay. All right. JoJo's up top. Nice. And then Ethan and then Lizzie's. All right, number 2. The more you perform trials, the closer the experimental probability gets to the expected value. This is called what? This is one of your assignments from right before the break. The more that you perform trials, the experimental probability gets closer and closer to the expected value. This is called what? It was actually the title of one of your homework assignments. Did you get it wrong? You all got it wrong? Did you get it wrong, Claudia? Oh man, what? What? Whoa. No, law of large numbers. Man, I already noticed a lot of you didn't do your 4.3 homework then. All right. All right. Next question. Let's see. Uh-oh. Faith is at first?
Yeah.
Wow.
I got one question.
Cheating? How is NCR typically pronounced when referring to combinations? This is in your notes. How do we normally pronounce NCR? What does that C stand for? Is it and choose R and cut R and copy R and create R? This was in your notes. It was in the first assignment. If you did that first assignment in the Pear Deck, it took you to another website to type these into the calculator. What does the C stand for? Choose, yeah. You're choosing R amount out of a total N possibilities.
No, I got kicked to 8. Believe it or not.
Okay, Lizzie's up top. Next question. So, a group of 30 runners are in a race. Only the top 5 finishers win a medal. How many combos of finishers can there be? Now you're using that NCR, which is the correct way to set it up. You're using the NCR. You don't have that calculator on your phone. I know that. So what's the way to set it up? There's 30 runners and there's how many different combinations of 5 finishers can there be? Good job setting up. Look, here's one tip for the NCR problems. The bigger number is always going to be the N, the first number. Okay? The bigger number is always going to be. It can never be the second number. You have 30 people, you're choosing 5 out of the 30. That's how you read that. If I were to have you pull up that website or use one of the graphing calculators to figure this out, the number is going to be super, super huge. It's a really big number. There's a ton of combinations. Okay. Nyla's on the streak, but Lizzie's still in first. Zach's second. All right, number 5. According to this two-way table, how many people like football? Look at the table. See if you can. How many people like football? Can you see it? How many people like football? Good. Yeah, guys, it's the total. I know it's kind of hard to see over there. The total is football. You look at the column total, it's 33 down there at the bottom. Okay. All right, I'm going to throw a curveball the next. Uh-oh, Nyla, did you miss that one? Or is he still up top? Yeah, she out.
I didn't even choose at all.
Oh, man. All right, 3 more. According to this table, what's the probability that a female has a sports car? Now we're looking at probability. Probability that a female has a sports car. Ooh, let's talk about this one for a second, okay? So basic probability. If I want to find the probability of a female having a sports car, I look over here and I see that there's 45 females that have a sports car out of the total, which is 240. So 45 divided by 240 will give me my probability. And then I can divide it in the calculator and get my percentage if I wanted to, okay? We're going to practice more of the dividing stuff here in a minute, okay? Draven is the highest climber now, but he's still on the top 5. Zach's taking the top spot. Lizzie, what does this stand for? Okay, Look at that notation. It stands for the probability of A and B happening. True or false? Is that the probability of A and B happening? True or false? A and B. Your probability notation. Your 9 seconds. True or false? That's false. Oh, that does not stand for and. What does that stand for? Or. Okay, the U is or. What would it look like if it was and? Upside down U, right? Okay. It's not an N. It's not even an upside down U. Okay. Okay. All right. Zach's still up top. And last question. There are 50 units in this Venn diagram. What is the probability of A? I'm not going to tell you what it is. You got to know what that symbol means. There's 50 total units in that Venn diagram. That's the correct fraction.
I got it wrong.
You mad?
I know it.
You mad?
Yeah.
20 out of 50. Okay. So what does this symbol stand for? And. Okay. A and D. Where does A and D show up in a Venn diagram? In the middle. Okay. In the middle. So it's just a 20 out of the total, which is 50. The outside is neither A nor D. And we're going to actually review what that looks like here in a few minutes. Okay. Question. All right. So that's a quick recap of some of the basic concepts that we did in the first half of the unit. Let's see who won. Zach, what happened? Who came out top? Claudia. You didn't know? Did you get the last one right?
Yeah.
Then the other people must have all gotten it wrong ahead of you. Good job. Okay, I'm gonna stop that for a second. All right. So here's for today's lesson. So stay with me, guys that are at home. That way I need to take attendance for you guys too here in a minute. So that review should help you guys also with a quiz. So I posted a quiz in here. Don't do it right now. You have until Sunday. Okay, Sunday to do this quiz. I don't know why my computer is running really slow right now, guys. I'm so sorry. It's in here. It's colored orange. It says quiz probability. Okay, it's only over this first 3 assignments. You don't need to do it right now. The reason why you have until Sunday is because I want you to use your notes and I want you to do as best as you can. If you're looking through your answers for the notes and you're answering this as best as you can, it's going to prepare you for the test in 2 weeks. Okay, so use that. We'll go over the answers next Monday. It's due on Sunday. We'll go over it on Monday, first thing on Monday. All right. What we're going to do today is 4.4, which is called conditional probability. I'm going to see if I can stop my thing from being so slow. Here's what I want you guys to do. Get your notes out, your journal, wherever you put your notes at. Start a new section. My God, my computer wasn't like this earlier. And title it 4.4 conditional probability. I'll pull up the slides here in just a second. Or get a blank sheet of paper. I think this is gonna all crash here in just a second. Holy crap. Can you guys still see me at home? Are y'all still there?
Yeah.
Okay. Hold on. Let me Just stop sharing for just a second. Oh. It's just like, well, I guess while it's thinking, at least it's still working. Okay, you can label it that. 4.4 conditional probability. You guys aren't going to write anything down until I ask you to write stuff down. There's a couple, first couple problems I just want to talk about. Let's just go through them, soak it in before you write anything down. Okay. It looks like I'm frozen on screen, but at least it seems to be working somewhat. Oh, now it's not. It's my computer. It's not the internet. I don't know why. My computer's just running real slow right now. I wonder if I just have too many things running. Let me see. There's something that's... See, my Zoom's all messed up. Gosh, dang it. Completely frozen. I don't know what to do. Shoot. You guys there?
Yes.
What do you guys see right now? Just me?
Yeah.
Okay. And for some reason I can't, it's not letting me, it's like frozen. It's not letting me share my screen again. Gosh, dang it. Look, if it, okay, let's see.
Oh wait, I think it's frozen. You're frozen.
If it kicks me out, can you hear me?
Yeah.
If it kicks me out, we all log right back in. Let me see. Of course, this has to happen right now on the one that I'm recording too. Well, I think it's gone, but well, are you guys, is it back? Am I back?
Yeah, I can see you.
Okay. I think I lost a few people. Hopefully they log right back in. Oh, sweet. Okay. Oh, jeez. All right. Hopefully this starts to load. It starts. Okay. Sorry, guys. I hope that you guys are back there at home. I hope we didn't lose anybody. I think everybody's here that was here before. Okay. I'm gonna give you guys some baseball. How many of you are baseball fans? Baseball fans, obviously. Who's your team?
Yankees.
Oh, wow. I just had this conversation earlier. Why are you a Yankees fan?
Just me and my uncle are.
You what?
Me and my uncle.
You and your uncle are Yankees fans? Okay, does that mean you're a Knicks fan too then? So you're just a bandwagon fan then? I'm just kidding. Who's your team, Christian? Rangers? I'm an Astros fan. Sorry.
Of course.
Why? Because they're
Texas.
cheaters? Because they're cheaters? We're in Texas. Well, I could be a Rangers fan.
Well, I feel like you like Texas.
Well, I'm a Tennessee Titans fan, but they used to be the Houston Oilers, and that's so.
Close enough.
Anybody been to a baseball game before? Okay, y'all been to baseball games, even like Round Rock Express here. What are some cool things they do at baseball games? They give away stuff all the time. Okay, especially if the team is trying to like get to a certain amount of runs or something like that. If you ever been to a UT basketball game, at the beginning of the game they throw these two dice, these big fluffy dice in the middle of the thing, and if the numbers on that dice, if the team scores that much of that day, everybody gets 5 free wings of pluckers. Like it's everybody's like what? No, at the UT basketball games. And so it's funny because everybody, you're 1 point away and everybody wants to get that next bucket. And as soon as that happens, the whole crowd goes crazy, even though it's like 10 minutes left in the game. Like, funny. Anyway, so this is a true thing. And back in 2010, the Tampa Bay Rays in Tampa, Florida, they did a thing that whole season. If Tampa Bay, whether they won or lost, got 7 or more runs scored, everybody got a free taco. You go up to the stand, you get a free taco, show your ticket, you mark it off, you get a free taco. Obviously, you want to get a free taco and the Rays win the game. Sometimes that wasn't enough and they still lost. Here is a two-way table that shows how many times there's 81 total games of home games, how many times that people got tacos or not got a taco, and how many times they won and lost. Okay, we've all seen this before. You don't need to write anything this down until I tell you to write something down. Everything's running smoothly, it looks like. Okay, help me figure this out. Don't write it down. Figure out what this probability is. What's the probability that a fan at a game in 2010 got a free taco and saw a Rays victory? Okay. First, in order to find the probability, let's find out how many times that happened. How many times did somebody get a free taco and saw a Rays victory? 13 times. In order to find the probability, I got to divide that by what? Why 81? That's the total. Okay, so 13 by 81. Here's my notation for probability of getting a taco and a win. 13 divided by 81 would be my fraction. And if I wanted to convert it to a decimal, I would put that into the calculator. When we're doing this for probability of this whole unit, how many decimal places were we writing the decimal version? 3 decimal places. Okay, 3 decimal places so that we can write the percentage in 1 decimal place. 3 decimal places were 0.160. You have to write that 16.0% to be correct. Okay. If you just put 16%, you're going to get points off because that is not exactly 16%. It was 16.0 something percent. And that shows us that it's been rounded. Okay. All right. Look at the way I've worded this next question. It's a little bit different. If we randomly select one of Ray's victories from 2010, what's the probability that a fan received a free taco? How is this question different?
So you have to put the losses in them.
We don't have to put the losses, right?
Oh, yeah.
Because we're only talking about what now? We're not talking about all the games. We're only talking about the wins. There's another way to word this. In other words, what's the probability that a fan got a free taco given that they won the game? Okay. This changes my probability and changes my fraction. There's a condition that needs to be met. that condition is that they won the game. So I'm only looking at the games that they won. Now my total is not 81. What's my total? 49. How many times did they get a taco out of those 49 times? 13. So my fraction is different. My fraction is only 13 out of 49 instead of 13 out of 81 because the wording changed. Okay, this gave me a different percentage too. I'm only talking about the times out of the times that they won. This is called conditional probability. This is probably one of the hardest things in probability for students to learn. So the first thing I want you to write down is just a definition for conditional probability and the notation. The notation is important because that line between A and B denotes that there is a condition that needs to be met. In this particular case, and when it's written that way, the condition is the second half of that probability notation. It's the B. So this is written as, or it's pronounced, the probability of A given B has already happened or already occurred. So this is the first thing to write down for your notes. And while you guys are doing that, I'll start taking attendance for the people that are here. Who's Ava?
Oops, I forgot to change my name.
All right, you guys need more time? Need more time at home, guys? Okay. Here we got 60 more seconds. Get that they're written down. Okay, again, so we're looking for a probability of A given that B has already happened. So in this particular case, B is the condition. When we look at these types of problems, we always kind of work a little bit backwards. And the reason I say that is I want to look at what the total for B is first, whatever that B might be. Okay, this is called conditional probability. Good, Jose? Okay. So I've already figured this one out. We just figured this out a few minutes ago. You guys gave me the correct answer. This is the way the correct notation is written. Probability of a taco given that they had already won. Okay. I'm going to give you a different problem. Again, you don't need to write it down. Think about what the fraction might be in your head. All right, you ready? What's the probability of getting a taco given that they lost the game? You don't need to write this one down. Think about what is the condition that needs to be met first?
You have to lose.
To lose. Okay, so we're just looking at the losses. Okay, those are the losses that I'm looking at. That's the only thing I'm looking at. So how many times did they get a taco? 2 times. Only 2 times out of 32. Not 81, but 32 because the condition is that they had to lose, right? So, and then I can divide that out to get my decimal and percentage. Easy or hard? You think this is easy?
Easy.
Sure?
Yeah.
Okay, I'll make it a little bit harder.
Pretty easy.
Do you think that's going to be the same thing as if I switch them around? Like, what's the probability of getting a taco given that they won? Or I'm sorry, what's the probability of winning given that they got a taco? Is it going to be the same thing just by switching those two words around? What do you think is going to happen? Same or different? You think it's going to be different? Okay. Let's try it out. There are different conditions. It doesn't necessarily mean it's going to be the same. It could be, but there are different conditions in this case. In this particular problem, the probability of winning, given that they got a taco, doesn't really make sense. But what's the condition this time? No. The condition is always the second one. The condition is what? They have to get a taco. So now I'm not looking at the total wins. Now I'm looking at the total tacos. Okay. So out of those total tacos, how many times did they win the game? 13. Okay. So 13 out of 15 total tacos. So my condition changed. My probability changed. It doesn't really make sense that they would win or that they would get a taco. That they would win based on the fact that they got a taco. Okay. But we can still find the probability of that, which is 86.7%. All right. Here's what I want you to write down. On your next part of your notes, draw a big rectangle that goes across the whole page and draw this Venn diagram as big as you can. Just goes across the width of the page. Okay. Because I want you to draw this Venn diagram really big. Okay. It doesn't need to take up the whole page.
Like this? Or do you want it like
Just, yeah, like that. Mm-hmm. Just across the width of the page. Okay. But you're going to fill something in here in a second. Let's review some of this notation. And this is actually, Faith, what you were asking about earlier during the quiz. Okay. So draw this really quickly. Doesn't need to be perfect. Just draw the big make sure there's enough room, a good overlap in that middle. If not, you just have to write small. All right. In this Venn diagram, where does the probability of A and B happen? In the middle. Okay, so this part right here is A and B. How do I denote A and B? With the upside down U. So it looks something like this. Put the probability of A and B notation in the middle of your Venn diagram. Anytime you're asked to find the probability of A and B with that notation, you're asked just to find the middle of the Venn diagram. Now, how do I notate this side over here? This side, what does this side over here stand for? The probability of A but not B. How do I put that? I put the C where? On just the B. Good. Claudia, you remember. This is why you got first place. All right. This is what the notation is going to look like. The probability of A but not B, or and not B. This is what the notation would look like for the left side. Make sense so far? You remember this from B. This is kind of a refresh. That's why I said review. This is a review. But I'm making you have it fill out a chart. See if you can fill out the other side, the B side. Fall asleep, Ethan? See if you can figure out the B side. The B side is the probability of B and not A. So literally just flip A and B around. Okay? Flip A and B around and have the C on the A. All right, what are we missing? How do I do it? How do I do it all together? What if I wanted all three of these things added together? What would I change in the notation? We put the U on there. What does the U stand for? Or. So the probability of A or B would be everything together. And I put the U instead of the upside down U. When it's one or the other, it could be either or it could be both. So you got to use both the or and add all three of them together. That's why I highlighted all yellow. You don't obviously need to do that on your paper, but I would use the bracket to show that it's all together for A or B. I'm missing one more thing. How do I denote whatever's left over on the outside? The neither part, neither one of them. I do one little thing. I change that and I do one little thing. Put the C on the outside. You're going to say it, Claudia. Why don't you just say it? Put the C on the outside. It's neither A nor B. Okay? Put the C on the outside and it's neither one of those now. So this tool right here, this graphic that I had you write is going to be really helpful for you answering any questions in regards to Venn diagram probability because it shows you where each part shows up and what you need to add together. Okay? Good so far. All right, you want to get a little bit harder? And these next two problems are going to be the ones that are going to be probably the hardest ones, but they're not that hard. Okay, we'll be done here in about 10-15 minutes. All right, ready? Can I move on? See any chat from home? Okay. All right, you do not need to. I don't want you to write all this down. Here's what I want you to do. It says, suppose that 60% of all customers of a large insurance company have auto insurance policies with the agency, 40% have a homeowner's policies, and 25% have both. Okay, here's what I want you to do. Label this one number 1, example problem on your paper, and draw that little Venn diagram real quick. Okay, label that number 1 and draw a little Venn diagram. We'll just do number 1 here.
Venn diagrams stress me out.
They don't stress me out, but I always make the first oval way bigger than the second one. You too? I don't know why it is. Like I can never.
Really crooked edges.
Yeah, I can never do it right. Like I literally, like this is what I always do. I ended up doing like, and I can't ever like overlap them right. Like that's why I did these on the PowerPoint. Same thing with the infinity sign. I can't do the infinity sign. Like I always do it wrong. I always just do it like an 8 sideways. Can't do it. All right. Let's fill out the Venn diagram first. Which number should we do first and where should it go? 60%, 40%, or 25%?
So 61.5%.
Why the 25%? It says both. It's the one that goes where? In the middle. All right. So 25%. Oh man, what that? Goes in the middle. All right. If I lay this down, it'll be a lot better. Okay. 25% goes in the middle. Now we have to be careful as we're working backwards. I can't just put 60 right there. Why not? Yeah, well, I have to. 25% is already in the middle. I have to subtract to figure out what's left over. What's 60 minus 25? 35. Thanks. 35 plus 25 is 60. Now that's my total. 60 is the total for that whole bubble. Okay, so we all see where that came from. 40 is Saint likewise. It's the total for this whole bubble, but 25% is already in the middle. So what's 40 minus 25? 15%. And what am I missing? The outside. 35 plus 25 is 60, plus another 15 is 75. So what goes on the outside? 25%.
Why 25?
It's what's left over out of 100. Since we're doing percentages, total's 100. Good so far? All right, label this number 2. Write down. This is what we're going to find. The probability of having a homeowner's policy given that they already have an auto policy. If you want to abbreviate this, just put P home / auto. Okay. P home / auto. I have a condition that needs to be met. Which one of these is the condition? Is the home policy the condition or the auto policy the condition?
Auto.
The auto policy is the condition. That's what I'm going to divide by. All right. So when I come up with my fraction here, auto policy is the condition. What's the total for the auto policy? No, the total for auto policy. The total for auto policy is 60%. You guys see that? That's going to go on the bottom. I'm going to divide by 60. Remember, we're always divided by the total, but we're only talking about the auto policies. What this is asking for is the probability of a homeowner's given that they have an auto policy. So out of that 60%, what percentage have a homeowner's policy? 25. Out of this 60 total right here, what percentage have a homeowners? Well, it's just that 25% in the middle. So this is how I'm going to divide. Use your calculator. Divide that out. 3 decimal places. What did you get, Faith?
0.416.
0.416.
Yes.
And what is that percentage?
41.6%.
Good. And for those that aren't sure, how did you get that?
Move the decimal point.
Move the decimal place 2 places to the,
Right.
or you could have just multiplied by
100.
100. Good. I think it's just because my computer's lagging for some reason right now, but this was writing a lot better earlier, just FYI. Okay. All right. Second part of this question, label this one number 3. Okay. Find the probability of an auto policy given if they have a homeowner's policy. Write the notation, but you can abbreviate. P home or P auto / home. Okay. That way you have some notes to look back on. Even if you don't have the prompt, you can see where the numbers came from. That's why I'm having you write those down. Okay. All right, which one is the condition this time? Home is the condition. So what's going to go on the bottom of the fraction? What am I going to divide by? By 40. Out of that 40%, what's the probability that they have an auto policy? So out of this 40 homeowners, again, it's just that 25% in the middle. Divide that to get your answer. Still as easy as you thought it was? A little bit? I'll test you on the next slide. There's only 2 more slides. Jojo, what'd you get?
0.625.
625, which is 62.5%. You ready to do one on your own? Or do you want a few steps ahead of me? All right, can I clear this out? All right, there's only 2 more slides, guys. Bear with me here. Clear. All right. Again, don't write the prompt. I want you to do this is going to be, whoops, where did it go? This will be number 4. This will be number 5, and this will be number 6. But this time I didn't give you the notation. I gave you the word. You had to put the notation correctly. So I'll help you fill out the Venn diagram first. Okay. Suppose you have a torn tendon and are facing surgery. Anybody had surgery before? No surgeries in here? Surgery? What? Oh, well, that's a surgery. I've had maybe I'll tell you guys a story one day, but I've had a twice collapsed lung and had to have surgery to correct that. Yeah, I was y'all's age actually, 16 years old, first time, 17 years old the second time. Almost died. Yeah. Y'all want to hear that story sometime? The orthopedic surgeon. So surgeries, a lot of risk. Some risk. So they could not work. They could get infected. So on. This particular one, as they're talking about here, says the orthopedic surgeon explains the risks. Infection occurs in 3% of operations. Repair fails in 14% of operations. Both infection and failure occur in 1% of the operations. What number do we put first? 1% goes where? In the middle. Okay. 1%. Don't forget that infection 3%, that's this total bubble. 1% is already in the middle. So what goes on the left? 2%, because 2 plus 1 is that 3% there. The failures is 14%. That goes this whole bubble, but 1% is already in the middle. So that leaves me with 13%, because 13 plus 1 is that 14 for failures. And figure out what's on the outside just to complete the Venn diagram. 13 is 14, 15, 16, so 84%.
Sure, I could not do the math.
You couldn't do it that fast?
No.
Come on.
Oh, so slow.
So, number 5 says, what's the probability that the repair fails given that surgery results in an infection? How am I going to write this? P. What comes first? Fails comes first. Fail or failure. I was going to do fail. Given that infection. Oops. Okay, that stands for infection, guys. Okay. All right. See if we can figure it out. Stay a step ahead. Two. Remember, when I do these, I like to do them backwards. So I like to figure out what's the bottom first. What goes on the bottom? The failure infection total. What's the condition? The condition is the infection. That's going to go on the bottom. What's the total infection rate? The total. The total is 3%. Don't forget the 2 plus the 1. Okay. So 3% on the bottom. Out of the infections, what percentage failed? So out of this 3%, remember, now we're just talking about this bubble now. What percentage failed? 1%. And I think we all know what 1 divided by 3 is. 0.3333 repeating, which is 33.3%. Number 6 is the other way around. Okay. See if we can figure out number 6. And then look up to see if you got it right. What's the fraction you got, Claudia? 1 over 14? You all agree with her? That's correct. Good job. Okay. Failure rate total goes on the bottom. Out of the failure rate, now we're just talking about that 1% in the middle. What was the decimal percentage you guys got? 0.071, which is 7.1%. Good. Those are a little bit harder, the Venn diagram ones. Than the no?
No, they are harder. But
They are a little bit harder. Okay. All right. That's it. All right. Last slide. Y'all ready? Get this over with. All right. Here's what I want you guys to do. If you want, don't worry about jotting down the table unless you want to reference it again to go back and look at some notes. These are the last practice problems. We're going to do them really quick and see if you guys can help me out. I'll put them up I'll write them down as you guys go along. Okay. Maybe I'll call on some people at home because y'all never talk. Number one, let's talk about what each of these means. And I forgot to do this too. When we're doing conditional probability, what's the key word? What's the key word we're looking for when we know that we're going to have that condition? In both of these, in all four of these problems, what was the big key word? Given. That word given. Given that, or of, or out of, or those are going to be key words that you see, given. All right. What number are we on? 7? Okay. So label this 7 through whatever. 7 through 12. So number 7, 8. Oops. I can't even write on this thing anymore. 9, 10. It's terrible. It's just I left everything running on during advisory. I'm gonna stop doing that.
Yeah.
I left Zoom up and down. I mean, I just don't have to close it from the morning. I should have just closed it. Okay, let's do number 7. All right, let's find the probability. We don't know what this table stands for. We don't really need to. What do you think? If you had a guess, what was this table representing?
What they like.
Who liked?
If they liked football or basketball.
Yeah, it could have been like we interviewed 100 students, and what was their favorite sport, right? You know, what do they play? Okay, or what sport do they play? Obviously, I'd be surprised if there were 13 females at a particular school that played football. Not that it's unheard of, but I think when I got it, it was like they interviewed 100 people on what's their favorite sport. Okay, I found it on a website. Anyway, so number 7, find the probability that somebody likes baseball. It doesn't ask like male or female. So what are you going to use? The total. So what's the total number of people that like baseball? 36. 36 out of what?
Oh, it was basketball.
Out of what? 100. Without a calculator, what's the decimal?
36%.
Yeah, 0.36, which is 36%.
Do we have to write down the decimal?
I want you to write it all 3 ways because I want you guys to get in the habit of doing all 3 ways. Yeah, with all your stuff here, because in the quizzes and the tests, you're going to see it in one of the 3 ways. Okay. All right. Alyssa, tell me what number 8's asking. Probability of
Female.
Being a female and
Maybe playing basketball.
Okay, so how many females play basketball or like basketball? Either way. 16. Okay, 16 females play basketball, and this stands for and, so it's got to be just that one, those 16 right there, right? So what's my fraction going to be?
16 Divided by 100.
16 divided by 100. Good. Do you need a calculator for that? I made this one easy because you don't need a calculator. 0.16, which is 16%. Curveball number 9. What does this stand for? Being male or liking football. Well, how do we approach this? You could either like football or you could be male. It doesn't matter, one or the other.
Would be the total males.
Total males plus
Plus the females that like football?
the female. Why can't I just add these two numbers together?
Because that already counts as 20.
Because a 20 would be counted twice. Okay, I can't just add those two together. If I really were just doing this, I could just be like all the males and all the people that like football would be those 4 numbers. Or Faith said the total males plus the 13 females that like football. It's the same thing. Okay, but we need to add all 4 of those numbers up, or you can add up 48 plus 13. It could be either or. They either got to like football or they could be male. Okay, so add all those up together and figure out what you get. So it could be all the males plus these 13 females that also like football. Add those two together. I think that would be the path of least resistance right there. 63? 63?
I might be wrong. No, 61.
Okay. 61 out of 100. That's 61%. Oh, I forgot the decimal. Ooh, another curveball in there for number 10. What's the difference with that one? There's a C.
And it says and.
It says and the C is on the outside. So here's what it's asking for. What word can you think of when you think of C?
No, I mean none.
Yeah, not that. Okay, not that. So it's not female and football. Well, where's female and football? How many are there female in football?
Female is 52.
13. Okay, female and football is 13. It's asking you for the probability of that not happening. How do I figure that out? There's a couple of ways to do it. Well, if 13 females like football, how do I want to find out the probability of that not happening? If the probability of it raining tomorrow is 70%, the probability of it not happening is
Okay. Oh, that's what I was going to
30%, right? It's just the rest of it. Okay?
Subtract it.
I can subtract that from 100. What's 100 minus 13?
77.
87. Okay. What do you think hold on, look at this. What do you think I would get if I just added up all the rest of these? I will get it. All the rest of those. Oh, it's hard to see. Okay, everything else, not that, is everything else, right? Okay, so if I add all these up together, I get the same 87 that you got out of.
Yeah, what are you adding up?
You can't see it? The 13, the 15, the 20, the 23, and the 16.
Also, all the other numbers.
Yeah, all the other ones. Okay. If you go back and look at your notes, the way that we set it up in your notes from the very first assignment, from the very first homework assignment, is we can just take the probability of this happening and subtracting it from 1. Okay. You can always do this. You can get the same answer every single time. Either way. So whatever is the probability of that not happening, or the probability of it happening, subtracting it from 1. If the probability of it's going to rain tomorrow is 70%, which I think it is, the probability of it not raining is 30%. 1 minus 0.7 is 0.3. Okay. This would give you 87 over 100, which is that 0.87, 87%. Okay. I'll go back. If you're trying to figure out what's the probability of something not happening, think of the rain analogy. Okay. All right. Last two problems and we're done. Find the probability of somebody playing baseball or liking baseball given that they are a female. Which one is the condition? Liking baseball or being female?
Female.
Being female is the condition. So I'm just looking at the females here. Okay. Out of the females, how many like baseball?
16. 23.
Baseball. 23. 23 out of what?
52.
Out of 52. Why not out of the total anymore?
Because they're just on the male female.
Because it's just out of the females. We have a condition that needs to be met. Condition is being female. I'll let you guys figure out the decimal and percentage on your own on that one. And then see if you can do the last one. And I'll put up the answer in a minute. See if you can do the last one.
That's 48, right?
48 the total males, yeah. But is that what you're supposed to be looking for? Claudia says no. What's the condition on number 12? The condition on number 12 is what? Being male or liking basketball? Liking basketball. It's always the second one. So I'm just looking at basketball for number 12. That's the condition. Out of those people that like basketball, how many are male? 15. So 15 out of what? 31. And that'll give you your final answer. I'll let you guys figure out the decimal percentage on that one. Do the decimal, 3 decimal places. Obviously, these are a little bit, those last two, a little bit harder, the conditional ones. That's why I went slow, and that's why we did a lot of these together. Listen up. So for this assignment, 4.4, I'm not assigning you any homework problems, okay? I'm going to give you a completion grade simply by taking a picture of your notes and those practice problems and uploading it to that 4.4 right now, okay? On the reason I'm not giving you a homework assignment is because Thursday's lesson ties into this, and I will give you some practice homework problems for that one once we do that. It'll be a lot shorter, okay? Trying to find a roulette table. If anybody has a roulette table at home, let me know. A roulette wheel.
Not a Wheel of Fortune.
Not a Wheel of Fortune. Okay, does anybody at home need this any longer? So what you guys are going to do right now, take a picture of your notes and take a picture of your the 12 practice problems that we all did together and upload into 4.4 homework, and you guys have a 100 for the day.
My back camera does not work.
Okay.
You want me to take it into? Yes, please. I've been